in the day one I'm going to choose a language. So I need to decide which language should I program it. So I choose Python. You can choose any kind of object oriented programming language such as C++, Java or Python. I choose Python, so I'm already familiar with it, that's why. And learn it if you don't know it, so go through the videos, right? So there is a channel called Telusco, so I'll put it in the description, right? So you can learn the basics of Python there. He clearly explained it, and if you already know it, just revise it. And the third thing is get started. So these are things that we need. I have already gone through it. You can go through the videos from the Telesco channel, or you can prefer the W3 schools for first three, right? Data types, list strings, if while statements and loops, right? Okay, so I'm going to do time complexity now, and I'll show it in the video as well how did it went. So let's get started. What is time complexity? Let's see what is an algorithm. Algorithm is a set of instruction to be followed to solve a problem, right? So let's say we have a problem. A user wanted to go from point A to point B, and you have written a solution with a set of instructions, like you go straight, turn left, turn right, and you reach the goal. You wrote a small solution which is a simple algorithm, and you want to measure it, right? So you want to see what how is the algorithm efficient to the solution. So you measure with time complexity and the space complexity. So before moving forward to the time complexity and space complexity, why it is so important? Because so in further run, a user came and wrote another algorithm which for the same problem, right? And it is much faster than yours, much efficient than yours. Then there's lot of benefit from the algorithm. How do you compare it? So we compare with the help of time complexity and the space complexity. That's why this time complexity and the space complexity is very much useful for an algorithm, and that's why we usually calculate it. Let's see how we can measure time complexity for an algorithm. In order to compare the efficiency between the algorithm, we use asymptotic analysis. So what is this asymptotic analysis? So let's take an example, like I have an algorithm and I want to compare with other algorithms. Okay, so let's say I have a problem, right? So a problem has millions of ways of solutions. Okay, and this, to compare with the other solution, right, we need to have same set of machines. Okay, so and we have millions of solutions, then we need same set of millions of machines, right? And that is very difficult to have same set of that large number of machines, same large number of machines, right? So in order to remove this machine dependency, right, in order to test this algorithm or to compare the efficiency of these algorithms, we use asymptotic analysis. So it usually checks the best case, average case, and the worst case scenarios, and it is denoted by asymptotic notations such as big O, omega, and theta. So for worst case scenarios, it uses big O notations, right? So we usually see big O notation, and it's very important, and we're gonna see what is big O notations, or when you program it, right? So you ideally check for big O of n. So how much is the time complexity of big O of n? Okay, ideally we check only for the worst case scenarios for an algorithms. Okay, so let's say what is an BIGO notation. It represents worst case scenario, as I said. So it represents tight upper bound. Beyond this, your answer never grow or go. Okay, so it has the equation which is f of n is equal to big O of g of n, where n is the size of the input. So at larger value of n, f of n is g of n. So for larger input size of n, f of n is g of n. For example, let's take this equation where f of n is equal to n power 4 plus n cube plus 2n plus 1, where n power 4 is the larger value of f of n, which is g of n, where g of n is equals to n power 4 because it's a larger value, right? So obviously g of n would be n power 4 according to the statement. So where g of n will give the maximum rate of growth of f of n at a larger value of n. So it says that g of n will give the maximum rate of growth of f of n at a larger value of n. Let's do this graphically. So coming here, so this is the big O notation. Okay, this big O notation where x-axis is the size of input which is n. Okay, and y-axis is rate of growth, right? This is rate of growth. And so when so we have g of n and f of n here. So we have k here. So at this point, this is the break-even point. Basically, k is an break-even point. So before this, the f of n value may be smaller than g of n, or may be greater than g of n, right? Okay, so after this break-even point, it always says g of n is greater than f of n. So after this k value, g of n is always be greater than f of n. So it says that the worst case always be g of n. The worst case after this point always be g of n. So for example, so to take what is this k, so let's take an example like let's take this equation only, so which is n power 4 plus n cube plus 2n plus 1. This is f of n. So we said that the larger value of n is f of n, which is equal to g of n. So where g of n will be n power 4, right? So for all these cases it's not true, because let's say my f of n value, let's say here I say 100 into n power 4, okay, and my g of n is n power 4, okay, and let's say my f of n value for smaller input, let's say like f of 10 would be what, 100 into 10 power 4. So it says that, it says that f of n is greater than g of n, right? So it says that we never touch this point. So before it, we say that f of n is greater than g of n. So that's why the graph, the dark black color is above the g of n. So after this break even point, the g of n will always be greater than f of n. So for smaller input, right? So f of n is greater than g of n. So in mathematical terms, it says that, okay, for mathematical terms it says that, so c is greater than 0 and n naught, such that f of n is less than or equal to c into g of n. This is c into g of n for all n is greater than n naught, right? So when n is greater than n naught, for all n is greater than n naught, it says that where g of n is always be greater than f of n. If not, f of n is greater than g of n, as we see that the smaller input, right? So this is what the big of n. So where we'll be finding the worst case scenarios, where we take the g of n as an the worst case scenarios always, but it is not always true, because for smaller input where f of n might be greater than g of n. So for larger input, right? So for larger input which relates to the worst case scenario, so it always be g of n is greater than f of n. Let's take an example. So coming to this example, for the case 1, we have an input n equal to 4 and we have a small for loop here, and in this for loop it goes n times and the complexity would be big O of n. This is simple because we think of n is equals, assume as a larger input, it can be very big number. That's why the worst case scenario would be big O of n. And coming to the case 2, right? So we have the same input, we have two for loops, and when we comes to the calculating the time complexity, f of n is equal to big O of n plus big O of n. Why? Because we have two for loops. That means big O of n is one for loop plus big O of another n for y for loop, and when you add it, right, so we have 2 big O of n, where for the larger input, right, for the larger input, so it doesn't matter for the constant, so we just ignore it. And because when you multiply with the larger input, it obviously goes to larger value. So that's why we just remove it and we just see the calculate the big O of n, and we just ignore the constants and just write it what is there. And coming to the case 3, in this case 3, this is quite interesting. We have nested for loop. Okay, so nested for loop means it has two for loop, which is n into another n, which is n square. Okay, and we have two for loops, that is n plus n. So we have n plus n, which is 2n, and plus n square, right? So we have an equation for f of n, and to calculate it, we will be calculating the larger value of n, right? Larger value of n of f of n, which is g of n. Here what is the larger value, which is n square, right? We just take it out, that we ignore, if there is any constant we ignore it, and we just calculate the big O of n. This is what it is, guys. This is about time complexity, and we hope you understand the big O notation and their analysis about asymptotic analysis and also the big O notation. Hope you understand it. Please, if you have any doubts, please put it in a comment. Please like and share and subscribe. This is day 1, guys. Let's go for the day 2. So I just read some articles, YouTube video, and came up with this. Hope you understand it. And I'm going to make another video for day 2, day 3, and also on. Let's stay tuned, guys. Bye. Thank you.